This video is going to focus on the last component of understanding how to write chemical reactions, which is the phase changes and other symbolization that we need for our chemical reactions. Okay. When I think about chemical reactions, I often talk about thinking about them like recipes. So far, we have learned and talked about how to write the ingredients, right? Step one of a recipe, what is going in and what is coming out. So writing those chemical formulas with subscripts, separating our ingredients with a plus sign and that arrow. Reactants are on the left, products are on the right, things like that when it just comes to the ingredients and the foundation of the recipe. Next, we've talked about balancing, which are those coefficients, telling us how much of each ingredient we need to put into our recipe in order for it to be successful. The last thing we haven't talked about is condition. If someone gave you the recipe for vegetable soup, for example, and they told you you need carrots and onions and peppers and garlic and chicken stock and cans of tomatoes or whatever. If you took it and you took the right number, I need 2 carrots and I need, 1 pepper. If you just all threw that in the pot, you still wouldn't get a successful recipe because the carrot needs to be chopped or diced, as does the pepper. And so that last piece for recipe is oftentimes the conditions, which for chemicals, we would talk about the state of matter, our substances need to be in order for the recipe to be successful. The other piece with that condition is, let's say you follow the recipe perfect for chocolate chip cookies and you cream the butter with the sugar and you mix all the things in and you beat the eggs. At the end of that, you don't have cookies. You also need to bake them at a certain temperature in the oven. So heat becomes a component for that chemical reaction to actually occur, whether it's spontaneous or not, and you need heat. So these are the additional symbolizations we haven't seen yet that we would write as part of our chemical reactions. So how it works is when you have a chemical, after you write down the formula and you balance it, you indicate its state of matter in a parenthesis after the chemical formula. So if that ingredient is a solid, it would say solid after it, or S if it's a liquid, L if it's a gas, G. A new condition that we've mentioned, but we haven't had a symbolization for yet, is AQ. And that are all of the solutions. So anytime you dissolve something into water, it's listed as an AQ because it's not technically a liquid, it is a dissolved solid. So that is the conditions for the substances. Each substance can be labeled with a what state of matter is it? If you need to put energy in to make the reaction happen, or if you get an output of energy out after it's over, you indicate that with a triangle. So a triangle indicates heat. If you have to put energy in, energy is a reactant then, it's an endothermic process. If you get energy out, it's an exothermic process, and energy would be a product. The other thing that sometimes you need is a catalyst, and a catalyst is something that speeds up the rate of a reaction. So sometimes I'm dealing with a reaction which is completely spontaneous. It's going to happen without me doing anything. All a catalyst is going to do is speed up the rate at which it's occurring to have it happen instantaneously or more quickly than it was happening before. The deal with a catalyst is it increases the rate, but it isn't part of the reaction, meaning it's not a reactant and it's not a product. So if I have a catalyst present, I actually write the symbolization of that catalyst above the arrow. That indicates the catalyst was used, but it's not a reactant and it's not a product. Its bonds aren't connected to anything when it comes to producing a product. So here's an example of what this looks like put all together. I'm going to use the decomposition of hydrogen peroxide you saw in lab yesterday. So hydrogen peroxide is H2O2, and in that bottle, it was 3% hydrogen peroxide and 97% water. So that's a solution, so it's labeled AQ. We produce oxygen, we know that from the flame test, and then also water. Water's a liquid, oxygen's a gas, so they're labeled as such. You should have noticed it got hotter using your thermometer, so you can see I have my heat symbolization on my product side. And then you put that scoop of potassium iodide in, which was a catalyst. So that catalyst is above the arrow, indicating it was utilized to make the reaction happen, but is not a reactant, nor is it a product. So that should help you see kind of how this goes together. Tomorrow in class, we'll do some more practice so you can better apply this. Have a nice day.